Wa alaikum assalam habibtis. Hey, but check this. Man had to go to the dentist car. One of my tooth was moving a bit wonky, a bit flexible. Now when man gets there, he tells me I need to go through the extraction process. So man had to give him the one happy sloppy, cause ain't no one taking my bones. Then he said, oh sir, if you don't go through this now, you'll be in a lot of pain in the future. I told him, are you dumb? My middle name is Pain, you little nan. He said, oh sir, we can give you the anesthesia to relieve the pain. I told him if you try to push a needle on my skin, I'ma catch both you and your Marge and put you both through the strangulation process. Anyways, look, let's jump straight to this. A little light work thing as usual. Man's gonna take difficult and make it into a little simplification. So give me a sec. Let me drink a little something. You don't know the pattern. Okay. Okay, a little something to get me started. So, before I start this topic, I need to get a sign off my chest. So basically, make sure you go watch part 1 first before we continue with part 2. You get me? Otherwise, part 2 is not going to make too much sense. It's going to be more nonsense. So make sure you go watch part 1, then come back and continue this video. Saying that, what I'm going to do now is man's going to write down a question. We're going to go through this quickly. Give me a second. Alright, cool. So let's just say, for instance, yeah, the question was telling me something like, let's say if the question was telling me something like, integrate 2 sin x and then cos squared x. Alright, cool. Now listen, make sure, as I said, yeah, make sure you go watch part 1 first, because I'm not going to be writing down the methodologies again, you get me? Man, I ain't got time like that, you get me? Man's a busy you understand? So make sure you go back to part 1 and then go over all the go over the methods and that, go over that stuff there, yeah. Alright, cool. Now watch this, yeah. So I'm gonna do now, man's gonna jump straight into this. Now the first thing you wanna do when you look at a question like this, you see this 2 here, whenever you see a constant, whenever you see a random number just sitting there, always put it on the outside. So man's gonna rewrite this as 2 integral sin x cos squared of x dx. That's the first thing you always want to do. Take the numbers out so, you know, it just looks a bit more simplification. Now, you see a question like this, what we need to understand here is that we've got 2 different trig functions. So the first trig function is sin x, and the second trig function is cos x. Okay, these are 2 different trig functions. Now, as you can see, one of them has a higher power of 1. So what I mean by that is this one has a power of 2, you get me? Even if this was 3 or 4 or 5 or 6, whatever it is, yeah? So what we've got here is you've got one that's to the power of 1, and one that's to the power of 2 or more. So if this was 2, if this was 3, if this was 4, it doesn't matter. Okay, this methodology stands still, yeah? As long as, given that this one is to the power of 1, yeah? Now watch this, yeah? What I'm going to do now is what you need to be doing as well when you see these types of questions, yeah? Alright, cool. So I'm going to rewrite this. I'm going to rewrite sin x. However, what I'm going to do for this one, yeah, is man's going to do big brackets. And this to the power of 2, man's going to take to the outside. Okay? Like this, yeah, up there. Remember, yeah, this and this is exactly the same thing. Now listen, I have videos on differentiating trig functions part 1, and obviously integrating using the reverse chain rules also. Go watch them both before you come here, so you're gonna fully understand what's going on, you get me? Like, you can't just jump straight into this video without watching, like, them 2 at least. Like, your differentiation, your integration need to be strong, fam, you get me? Strong, fam, you get me? But anyways, I'm gonna carry on. Alright, cool. So now, when you've done this, what you need to be asking yourself, yeah, is what happens when I differentiate this? Now remember, this is the big brackets with the power, okay? So therefore, this is the inside. Now remember, as from the previous videos, if this is the inside, therefore, this has to be the outside. You get what I'm saying? Obviously, if I'm saying this is the inside, therefore, this has to be the outside. You get me? One of them is inside, one of them is outside. One of them is outside, one of them is inside. You understand? So cool. Let me wrap this out. Now, as we know, what happens if I differentiate the inside? If I differentiate the inside, if I differentiate cos x, it's going to give me minus sin x. Alright, cool. Now listen, it's not a coincidence that this sin x here is also sitting on the outside. Now listen, man don't care about the negative. This negative here, man don't really care about. What I do care about is the fact that the sin x is here, the sin x is here. Calm. Now watch, yeah? Now once I've realized that, we're going to go through the step-by-step integration using the reverse chain rule steps, yeah? So what I'm going to do, I'm going to rewrite 2 sin x. Man don't care about 2 sin x, yeah? The 2 sin x, obviously I've gotten from here and here, yeah? Light work thing. Once I've rewrote them, what I'm going to do is man's going to integrate this thing here. Now, if I integrate this, remember the steps here. We first rewrite the inside. So man's going to rewrite this. Remember, this whole thing is the inside, yeah? Rewrite the inside. Add 1 to the power. If I add 1 to the power, 2 plus 1 is giving me 3. Times it by 1 over the new power. The new power is 3. Times it by 1 over the derivative of the inside. So what happens when I differentiate the inside? If I differentiate the inside, remember we just found out it was minus sin x. Alright, and then what I'm going to do now is I'm going to put plus constants. Now, as you can quite clearly see, what happens here, remember this whole thing's being multiplied, yeah? What happens here, yeah, is this sin and this sin cancel out. Calm! Now remember, that was the main aim here. That's what we were trying to do. Now, what's left is, let me just rewrite everything on the top here. Let me put it in blue, yeah? So you've got the 2, you've got the 3 on the bottom. So that's 2 over 3, man's going to put 2 over 3. And then you've got the cos cubed x, yeah? So you can rewrite that as cos cubed of x. And then, of course, the plus constants. Okay, calm. Now listen, I hope so far you're understanding what I'm doing here. Okay, so I hope so far you've understood what's been going on. So essentially what I did is, when I saw this question, the first thing I did is I took the 2 and I put it on the outside. Calm little light work thing. Then what I did, the one that has a higher power of 1, which is this one here because it has to the power of 2, what I did is I put it in big brackets and I put the 2 on the outside here. Calm. Then I realized when I differentiate the thing inside of the big brackets, yeah, what I realized is when I differentiate cos x, it's going to give me minus sin x. And as I realized, sin x is also sitting on the outside. Okay, so that's when I used using the reverse chain rule. Now, this methodology is obviously in part 1. So if you don't understand what happened here, you need to go watch part 1 first and then come back to this little light work thing. Okay, so now what I'm going to do, I'm going to rub this all out and we're going to look at a different type of question now. Get me? We're going to make sure we become perfecto in these types of questions. Give me a second. Give me a second. Give me a second. Alright, cool. Let's say if the question said something like 5 sin cubed x cos x dx. Okay, now listen up here. Listen up. Remember, the 5 is a constant. I'm going to put down the outside. Okay? Because therefore, I don't want to be too confusion. You get me? So cos x dx. Okay, little light work thing. Now, remember as I said, yeah, this is to the power of 1. However, this one's to the power of 3. So what man's going to do is man's going to rewrite this, yeah, big brackets, and put the 3 on the outside. Automatically, yeah, what happens now is, remember, this becomes the inside. If this is the inside, therefore this is the outside. Okay, now I say to myself, what happens when I differentiate the inside? What happens when I differentiate sin x? It gives me cos x. Okay, now listen, it's not a coincidence that this cos x here is also on the outside in this integral here. Okay, so when I realize this, I say to myself, reverse chain rule. Now listen up, yeah. We're getting lucky here that it's giving us identical answers like cos x. Even if it was giving us something like this, yeah, even if it was giving us like I don't know, like 4, you know, cos x. Even if it was, remember, even if it was given 4, it doesn't really matter, okay? What really matters is that cos x is here, because the main aim here is to cancel out this cos x. That's all I want to ingrain in your skull, okay? Now I'm going to rub this out, give me a second, and let's integrate this using the reverse chain rule. Okay, cool, so what I'm going to do, the 5 I'm going to rewrite, the cos x I'm going to rewrite, and I'm always only going to integrate this thing here. That's what we did the last question as well. The one with the big brackets we integrated, yeah? Okay, cool. So if I integrate this, remember the steps, yeah? Rewrite the inside. So man's going to rewrite the inside. Add 1 to the power. If I add 1 to the power, times it by 1 over the new power, times it by 1 over 4, times it by 1 over the derivative of the inside. Now, what happens when I differentiate sin x? If I differentiate sin x, gives me cos x. Calm. And then remember the plus constants. And also remember this will be multiplied. Therefore, as you can see, boom, boom, the cos x cancel out. That's what we've been trying to do here, yeah? Then what I'm going to do, man's going to rewrite this up top, yeah? So the 5 here, 4 on the bottom, that's 5 over 4. And then this is sin to the power of 4x, so I can just rewrite that as sin to the power of 4x like that. And then man can do plus constants. Okay, listen, I hope so far you're understanding what I'm doing here. Now listen, if you're not, obviously listen, just watch this again and try to ingrain it in your skull, okay? It's really important. These types of questions are really, really important. Now man's gonna go through some more questions to fully ingrain it in your skull. Okay, cool, let me just rub this out. Give me a second. Give me 1 second. Little light work thing. Okay, let me bring up another question now, yeah? Alright, listen. Basically, yeah, there's one question. Actually, nah, listen, I don't know how many times this might happen, but this might happen a few times. Basically, the method I've gone through right now is a very, very good method for you to understand and learn, yeah? However, there's a few questions I want to go through, yeah, in which this one's a bit of a cheeky one. You understand? Now, let's go through it quickly, yeah? Let's go through this quickly, yeah? Let's say, for instance, the question was something like, I don't know, like, let me think. A third, let's say, 10x sec squared x. Okay, so now remember, yeah, normally what we do, yeah, I said to you, yeah, the one with the higher power 2 here, we're going to take it out and make a big brackets. So let me do that. And then the third, obviously, I'm going to put on the outside, yeah? So I'm going to put the third on the outside. I'm going to rewrite 10x. And then the sec squared x, what I'm going to do, man's going to put big brackets. Sec of x to the power of 2 like this, dx. Okay, now listen, what I say to myself is, this is the inside, yeah? What happens when I differentiate the inside? It gives me, when you differentiate sec, obviously, listen, this is given to you in the formula book, yeah? So you can get given this, yeah? But what happens when you differentiate sec x? It gives you sec x tan x. Okay, now what's really, really important here is that these are not exactly the same. Normally this and the one on the outside need to be exactly the same. The only thing the same is the tan and the tan. However, for some reason this question still works, and the reason it works is because this sec x will eventually cancel out one of these sec x's here. Now I'm going to show you what I mean for this question. This one's a very, very weird one, yeah? Now I'm going to show you. So obviously we just found out what happens. Now listen. I'm just showing you this for the purpose of just showing you how the method that I've shown you can also be worked differently in these situations, okay? Because it will still work. It will still work even in this situation. And I'm going to show you how, yeah? So what I'm going to do, I'm going to rewrite a third 10x. And remember the methodology, yeah? What we do is we integrate this. So I'm going to add 1 to the power. So the first thing I'm going to do is I'm going to rewrite the inside. Add 1 to the power. 2 plus 1 is giving me 3. Times it by 1 over the new power. Times it by 1 over 3. Times it by 1 over the derivative of sec. If I differentiate sec, it's going to give me, as I showed you, sec x tan x. Okay, little lightweight thing. And obviously remember the plus constants. Now listen, yeah, listen. As you can see, the tan and the tan cancel out. Very, very good, yeah? But listen up. This sec, I'm not liking the look of that. Now we're lucky, we've got sec cubed divided by sec to the 1. Okay? Now let me just simplify this quickly, yeah? So let me just simplify. So we've got a third here, that's going to be 1 over 9. A third times a third is 1 over 9. We've got sec cubed x here. Times it by 1 over sec x, yeah? And then the plus constant. Now, as you can quite clearly see, this sec x on the bottom is sec to the 1x, yeah? So what you could do, sec cubed divided by sec to the 1, you take them away. So this 3 minus this one gives you 2, so you get sec squared, and that's your final answer. 1 over 9 sec squared of x plus c. You understand? I hope you know, you understand what happened here, okay? This one was a very lucky situation. You could have done this another way as well, but I just want to prove to you that this methodology man's teaching you is a good methodology, okay? Alright, cool. Let's look at a different type of question now. These are involving trig functions and all this stuff, yeah? Now remember, you need to go watch reverse chain rule part 1 in order to understand the next question. Because I can't be asked to be going through every single methodology and every single question 100 times, you get me? Because then you're going to get tired, especially for those who have watched it. Let's say if the question was 2 sec squared of x, yeah, e to the power of, let's say, tan of x plus c1. Okay, now listen. When you're integrating exponentials, I've gone over this in part 1. When you're integrating exponentials, what you do is you rewrite the whole thing and then you multiply it by 1 over the differentiated power, okay? Now, what's really, really important here is, firstly, I'm going to take this 2 outside as per usual. E to the tan of x plus 7. Now, what's really, really important here, yeah? You wouldn't treat it just like we've been doing before, because remember, as I said, when you integrate exponentials, it's a bit more different. when you integrate exponentials, the power becomes the inside, okay? So this is the inside. Therefore, if this is the inside, yeah, this is the outside. Okay, now watch this. What happens when I differentiate the inside? What happens when I differentiate that power tan of x plus 7? If I differentiate tan x, it gives me sec squared. Come, now listen, it's not a coincidence that this sec squared here is also sitting on the outside here. Once you realize this, okay, man's going to use reverse chain rule. I'm going to use the exponential rule, okay? So let me go through that with you now. What you do is I'm just going to rewrite 2 sec squared x as always, because we don't care about 2 sec squared x. What I'm going to do is man's going to integrate this here. Now, when you integrate the exponentials, what you do is you rewrite the whole thing. So man's going to rewrite this whole thing. So e to the tan of x plus 7. And then what I do now is I times it by 1 over, yeah, the differentiated power. What happens when I differentiate the power? Gives me sec squared of x. And then I add constants. Okay, now as you can clearly see, sec squared cancels out with this sec squared. Calm, this is what we needed. Your final answer is the 2 here, which I'm just going to put here. And then the e to the tan x plus 7. Now, obviously, as you can see, different functions you integrate differently. Yeah, it's really, really important you understand the differences between these, yeah? Different functions and different integrals are integrated differently. This here was just for the practice, to make sure you understand what's really, really going on. You understand? So listen, I hope this video helped, you know, better your understanding of how to use reverse chain rule. Don't watch that. More videos coming soon. Love.